Hello and welcome to my new YouTube channel. In this video I want to show you a simple but extreme efficient upgrade for your 3D printer. It's possible to install it on nearly every printer out there, but I mainly focus on the installation at your Anycubic Vyper or Kobra Max, since these share the same printhead. And the upgrade I'm talking about is an all-metal hotend made by E3D. It's called the Revo-6. And this hotend comes with an, in my opinion, game-changing feature, which for itself would be worth to give it a try, but while testing I noticed even more arguments that could make this thing interesting for you. And exactly that's the reason why I decided to record this video. But why is the Revo so special? Which improvements could you expect? And how can you install it safely into your Vyper or Kobra Max? All these questions will be answered in this video. But first I would like to announce that I will randomly choose one subscriber of this channel until the end of November to win 1 kilogram free PLA. So either if you like my video, want to support me in advance, or simply interested in free filament, feel free to hit the subscribe button. And for the beginning I would like to start with a pretty promising comparison. This temp tower was printed with the stock hotend, while this one was printed with the Revo-6. And I know there are other test prints like this mini benchy for example, but I tested so many filaments on the Revo using a temp tower that I was able to play domino with them afterwards. This is the reason why I will stick with them mainly. And if you have never heard of the Revo before, I will first start to show this unique feature what makes this hotend so special. So let's start off with the nozzle. Normally if we change the nozzle we have to insert the nozzle into the heater block and screw it in until it reaches the heat break. Therefore we have to heat everything up and use some tools so we won't hurt ourselves. After that we hope that everything is tightened up properly so no filament will leak out of the hotend. To fully eliminate the risk of getting such a messed up heater block, E3D had a pretty interesting idea. E3D thought, why can't we just take a bimetal heat break, push it together with a brass nozzle and get a 100% leak tight connection where we have no risk anymore that filament can leak out of the hotend. And exactly this interesting solution will bring us now to the next big plus of this hotend. You can see me here at my Vyper with the installed Revo-hotend. Nozzle is cold, I can touch it without any issues. And everything you see from now on is non-spectacular, or well, in my opinion it's pretty spectacular, because all you see here is the nozzle change. No tools, no heating up, nothing, like 10-15 seconds, I don't know, and here it is. Just get the new one you want to insert, in my case it's 0.4. And from now on the most difficult part is simply to just aim correctly into the heatsink so you can screw it back in. And this hotend won't even give you a chance of doing something pretty wrong, because the heat break on the nozzle has something like a little end stop, and if this hits the heatsink you can't screw it in any further and you get a pretty good feedback if you screw it in, so there's no chance of over tightening or anything. So let's jump right into the next possible advantage, and that's the heat up time. Since the Revo-6 uses a pretty special heater block called heater core, I was quite certain that there might be a difference in heat up time. So on the left you see my Vyper with the Revo-hotend, and to the right you see a Vyper with a stock hotend. Both got the command to heat up to 200 degrees, so let's have a look. And already after 45 seconds the Revo-hotend has hit 199 degrees, while the stock hotend is still at 115. And as usual the next step is the stabilization of the temperature. So as usual the hotend will overheat a little bit and then try to lower it down to reach the 200 degrees. And yeah, after 59 seconds the Revo-hotend is already finished with the entire heating up process, while the stock hotend is still at 142 degrees. And after 1 minute and 41 seconds the stock hotend is still just at 199 degrees, so no stabilization, it's stabilized at 2 minutes 11. So we have 59 seconds for the Revo and 2 minutes and 11 seconds for the stock hotend. And this means time saving, less overcooking filament and less filament leakage. And before we dive into print comparisons, I would like to point out that I don't want to make this sound like you can't even achieve a good print with a stock hotend. All you see in this picture was printed with the stock hotend and I was super happy. But there are specific filaments and also some situations where we can't get the best quality out of the stock hotend. And that's where my following temp towers come in. In case anyone is wondering, you will see two different heights of temp towers, because usually with the stock-hotend I printed pretty big towers, but for time and material saving I decided to print a little smaller ones with the Revo, but the model is exactly the same. And now let's start with the filament you've already seen at the beginning of this video. You can see that the hotter temperatures are absolutely messy, but also the lower temperatures don't really show a pretty good print surface. And I wasn't able to use this filament at all with the stock-hotend, so I tried to give it a shot with the Revo and I was beyond impressed. Just look at this, this is a perfect temp tower. There's one string at 220, but that's it, it's perfect. Especially if you compare the overall surface quality, it was really a huge improvement to the stock one. And if you look closely to same material, same brand, just different color, we have the exact same improvement right there. I know some of you might ask themselves if this is even the same PLA profile. I wasn't sure myself after I got the first perfect temp tower in and I checked, and it's 100% the same PLA profile used in the same Kobra version. And to be honest, after I printed this temp towers, I was certain that I have to make a video about it, because that's beyond impressive in my opinion. This temp tower right here got an overall temperature increase by 20 degrees Celsius, and that's because here we don't have PLA, but that is PETG. That's my first ever PETG temp tower, and I'm very happy how this turned out. Again, no stringing, perfect bridging, even though I was using 100% fan speed. Again, a perfect surface in my opinion, so I'm very happy how this turned out. Right here, a little bit of silk filaments. You can see the bridging got some issues in colder sides with the Revo, but overall still 100 times better than with the stock-hotend. And as it seems, not even wood PLA is a big challenge for the Revo-hotend, so also this tower looks pretty good in my opinion. But then I made a pretty weird discovery. If you look to the tower on the right, printed with the Revo, it looks perfect, but it didn't finish, and that was not the only filament, because some filaments showed an issue if you print it a little bit too cold with the Revo, mostly in the 200-205 range. The overhang started to curl up, which leads the temp tower to get knocked off by the nozzle at some point. I tried to capture it with this video, but I'm not sure if you see it pretty well right here on the left overhang, that there's curling up a little bit. And finally, a good message for people using the stock-hotend. You can see you also are able to get pretty well temp towers with stock-hotend, but it depends on the filament. This filament by 3D called EcoPLA was a pretty good example. Still, the Revo one here looks a little bit better, but I would still be happy with the stock one, to be honest. So my conclusion would be that you have a really big advantage with the Revo-hotend over the stock one, but if you use a little bit too low temperature, your prints will fail way quicker than with the stock one. That's the only issue you have. And I also made my own overhang test, printed with 60mm on the right, 50mm on the left, and the last one with 70mm. My test goes from 40 to 80 degrees overhang, and you see the stock cooling is quite well with the Revo, so there's no issue at all. In the following, I would like to show you some of the cool prints I was able to achieve. I used different shapes and also filaments, but the next model is by far my favorite. It was printed at 60mm per second speed, 0.16mm layer height, and yeah, using tree supports for these little stones on the hand for sure, but it turned out overall very nice in my opinion. Next, I would like to show you the different versions of the Revo that are existing, and also the one we need for our Anycubic Vyper or Kobra Max upgrade. First up we have the Micro, which is the lightweight version in the Revo line. Next we also have the Voron, specially designed for the Voron printers. There's also one version to cover Creality printers, and also an Hemera XS, which is a direct drive variant. Then there's a version for the Prusa MK3 with matching cables to make it a drop-in replacement. And then we have the Revo 6, that's the one we need for our Vyper or Kobra Max upgrade. If we take a look at E3D's homepage, we can see that in the Revo 6 bundle there's also a hotend fan included. It's cool that we have it, but we won't need it because the Vyper or Kobra Max hotend fan is working quite well. To the right we can see the button tube holder, which will ensure a tight grip to the tube in combination with this little clip. Next we have the aluminum heatsink, which is basically the only difference between the previous versions we've looked at. Next we have this little spring right here. That's a connection between the heatsink and the heater block, which ensures that the heater block won't fall off if you unscrew the nozzle. Then we have this very well performing heater core heat block, which in combination with the spring, the heatsink and also the button tube holder is actually the entire all metal hot end we have right here. If we scroll a little bit further down, we can see that the heat block and also the nozzles are already equipped with heat socks. The colored heat socks used for the nozzles are also the indicator for the different nozzle sizes you're using. So, except for the two extension cables used for the heat block, here's everything shown you will receive if you buy the Revo. If we now scroll through this section and click on any of those items, we will be redirected to the page where we could buy that specific part as a spare. And if you want to get one of these hot ends, please make sure you get the right voltage for your printer. In case of the Anycubic Vyper or Kobra Max, it is 24 volt. If you want to install the hot end properly in your Anycubic Vyper or Kobra Max, you will need a few things first. You'll need a crimp tool, two JST PH and XH connectors, as well as matching PH and XH plugs. Then the two extension cables come with the Revo and 4 M3 12mm screws and M3 nuts. Since I didn't own a crimp tool or connectors previously, I just went to Amazon and found a pretty nice set that contains enough spare parts. And the last but not least thing we need is a printed adapter so we can still use the auto bed leveling of our printer. You can find the download link in the description and make sure you activate tree supports to get the best possible result, since this thing will have to fit as good as possible. To provide the best fitting with the heatsink, make sure you change your slicing tolerance to exclusive. If we have all the requested items together, we can start with the short but important wire modification. First, to make sure that we plug the extension cables into the correct cables from the heat block, the white one into the thermistor cable and the black one for the heater cable. If you look at this graphic, imagine to cut the extension cables right where they end at this image, since that's where we'll install our new JST plugs. Here I would just like to show you the stock hot end again. You see that the thermistor uses the smaller PH plug, while the heater uses the bigger XH plug. And that's exactly what we need at our Revo to make it work. These are now the two extension cables we are working with, the black one from the heater and the white from the thermistor. The end with this plug is the one that we won't need and we cut away. From the previously shown connection, I would recommend that you use like 3 to 5 centimeters of the cable, because we don't have too much space in the printhead. And just to be 100% sure, I show you the plugs again. Here we have the big XH and the small PH, and also the matching connectors. Since I will show you the following steps on the black cable which comes from the heater normally, I will use the XH parts. And just in case you haven't previously worked with such connectors, I would like to tell you how they work. The bigger flaps right here will later hold onto the wire's coating to keep it in place, while the smaller flaps in the middle will hold onto the inner wire itself to provide an electrical connection. And the last part of our connector will be inserted in the plug afterwards, where it snaps in place and holds everything together. So the first step we will have to do is to remove about 2 mm of the wire's coating. We don't want to remove too much of this coating, because that could lead to some issues later when we plug it together. Now we can twist the end of the wire. Since crimping is a pretty filigree work, I personally like to insert the connector into the crimp tool before adding the cable, to get a better control of the process. Just very firmly to not bend it yet. Here you can see it a little bit better in close-up. And now we can insert our cable, but just as far that the rear flaps are even with the coating, so they won't hit the wiring itself. Also make sure that the end part of our connector, which will be later inserted into our plug, won't get squeezed or harmed in any way, because this thing has to stay as it is. And if you're sure everything is fine, just go for it, crimp it and take a look. And this is how it should look. You see that the rear flaps have a pretty nice grip on the coating, and the inner flaps are holding the wires pretty well. And if we now take a closer look at our plugs, we can notice that on the other side there are two gaps. And each of these gaps is for one part of the cable with a connector. If you look closely, you can see this little barb right here. This will just snap into place in one of these gaps. Like this, exactly. And now you just have to repeat the steps on the other side and also insert it into the plug. Then your first cable is finished. Now simply repeat the previous steps on the thermistor cable as well and you're done with the crimping part. In the next step, mount the adapter on the new hot end using 2 of our screws and nuts and make sure they have a pretty tight fit. Now loosen the 4 screws on the backside of a printhead and remove the front cover containing the fans. With the remaining nuts and screws, we will now simply mount the adapter into the printhead. And now we can take care about our cables. I choose a way to simply re-enter the printhead from the backside, guide the cables through the backside of this hot end and make sure that there's no unnecessary pressure against the hot end itself, otherwise the level sensor could get irritated. Now simply plug them in and reinstall the front cover of the printhead and you will be ready. Now you can power on your printer and connect it to your computer to start a pit tuning. If you never did this before, I'm happy to guide you through. First you need to start our part cooling fans, setting the code M106 spacebar S255. And now simply start the pit tuning by entering the code M303 E0 C5 S210 U1 and send it. After our pit tuning was successful, we want to save the 3 last lines in our firmware. Therefore we just sent the code M500. If we want to make sure that the saving process worked properly, we just shoot the code M503 and search for the pit tuning numbers. If these are the same as shown before, everything worked properly and we can disconnect the printer. And after all these steps, you're finally ready to use your new Revo 6 hot end in your Anycubic Vyper or Kobra Max. I really hope I was able to show you the benefits of this upgrade and also to provide all the information you need for the installation. And yeah, I'm aware of my English skills not being the greatest, but I gave my best and I really try to improve on future videos. Finally, I would like to thank everyone for taking the time to watch my video and maybe even leaving me feedback down below. Hopefully we'll meet each other again in one of my future videos. I would be super happy about that, and don't forget that one of the subscribers can win 1 kilogram of free PLA until the end of November. And now enough from my side. Thank you again for watching this video. Stay safe, have a wonderful day, and hopefully we see each other in the next video.